All right, everyone, let's begin. So we started binomial expansion in our last session. I also uploaded the worksheet for this topic on Google Classroom. Those of you who are not in Classroom yet, please make sure that you join that because all the course material is going to be uploaded there. The worksheet for binomial is also there. You can actually start working on that. You should have started working on that already. Today, we are going to be doing some practice questions from that worksheet. I'll quickly review what we did in our last session. And then we are going to be doing some questions from that. And hopefully, if we have enough time at the end, we will do one new concept as well. Otherwise, it might be tomorrow. But today, we want to focus primarily on doing some practice questions, inshallah. Okay, so that's the plan for today. Now, before we start, I would want to hear from some of you as well. Can you let me know how many questions from the worksheet were you able to attempt? Because it's extremely important that you do practice alongside. So I would appreciate if you try the worksheet questions after every class, the concepts that we do. You should start doing questions on that right away. So can you tell me how many of you, so you can raise your hand for this, how many of you attempted at least 5 questions from the worksheet? Can I raise your hands if you attempted at least 5 questions from the worksheet? So all I'm concerned about is whether you're attempting questions or not. If you get them right or not, that's something that you'll only find out once you attempt the questions, right? So I only am interested in whether you've attempted or not, because that's the least you should be doing. And then you'll figure out if you have any problems, and then you can come back to class and ask me those questions, and that's how you learn. Okay. So, okay, so only Ira has done more than 5 questions. Okay, how many of you are done with at least 3 questions? At least 3 questions from the worksheet. Again, I'm talking about attempting. Okay, so not many of you. Please make sure that you're doing this. That's the whole point of these classes, that you do practice and then you get stuck somewhere, then you ask those questions in class, and that's how your concepts will get clear. So please start doing it. Do not leave it for later. You'll start forgetting everything, and then there's no point. If you don't practice the concepts that we do in class for over a week, trust me, you're going to start forgetting them. So practice them right away. That's how you'll retain those concepts. Otherwise, you'll be panicking at the end that you are forgetting everything. The reason for that would be that you're not practicing enough, because once you do enough practice, the concepts start making more sense. You can retain them better. And so that's really, really important. Okay, so we started this topic in our last session. It's a pretty straightforward topic. Binomial expansion. So it's about how you can expand expressions like these that have 2 terms in them, and then you have a whole power on top, right? So we know, for example, already a plus b whole squared, that is a squared plus 2ab plus b squared. But what if we have another power? If we have a cube, power 4, or even higher powers, how do you expand those powers? This is the formula that we said we have for it. Okay, this is the formula, the binomial formula that we will be using. This notation is important. NCR, you should be able to evaluate this on your calculators. For example, 11C4, 6C2. This function is written on top of your division button, on top of the division button on your calculators. NCR, you need to be able to use that and then expand expressions like these using this formula. This is what we discussed in our last session. This is important. We'll come back to this in some time. every term in this expansion is actually of this form: NCR a raised to power n minus r into b raised to power r. It's just that the value of r keeps changing. So in the first term, r equals 1, then so in the first term, r equals 0, then r equals 1, then r equals 2, and so on, until in the last term, in place of r, you have n. Okay, so that's what we did in our last session. We did some examples on this. For instance, we learned how to expand x plus y whole raised to power 4. We talked about some, in fact, let's look at the other expansion as well. We talked about x minus 2y whole cube, how we can expand this. If you have a negative sign here, you have to remember that you have to include that as the value of b. Then we did a couple of other expansions. Then we also talked about the form that is given in the formula sheet. This is how the formula is given in the formula sheet. There's a slight difference from the notations that we have used here with what they give in the formula sheet. In the formula sheet, they write these column vectors like this: n1, n2, n3. This is actually just another way of writing nc1, nc2, nc3. The rest of it is exactly the same. So you should be familiar with this notation as well, because sometimes what happens is in the exam, you forget the formula. So in the formula sheet, they have it there for you, but you need to be able to understand that this means NC1, this means NC2, this means NC3. All right, the rest of it is the same. Then there were some properties of this NCR function that we also said you need to be aware of. For example, one condition is that in this function, the number at the bottom cannot be bigger than the number at the top. So you can't have, for instance, 6C8. That would be undefined. The number at the top cannot be smaller than the number at the bottom. So n has to be greater than or equal to r. They can be equal, but n cannot be smaller than r. Okay, that's what we learned. Then there were some properties, some other properties as well. NC1. So anything C1 is just the number that we have on top. That's n. For 6C1 is 6, 7C1 is 7, 10C1 is 10. If you have 0 here, the result is always 1. If you have the same numbers here, the result is always 1. So these are some important rules that you need to know about here, because you sometimes need to use them in some questions. Okay, so that's what we did in our last session. Now today, we are just going to do some practice questions from the worksheet. Okay. Now you are going to let me know. So this is how our classes are going to be. So we are going to do some concepts in class, and then I'll be uploading a worksheet like I did. And then we'll be doing some questions from that worksheet. In particular, those questions that you ask me about. Okay, so you will be trying the questions yourself. You'll get stuck somewhere, inevitably. That happens to every single one, to every single student. You are going to get stuck at some point. But then what you do is you come back to class and ask about that. Okay, and that's how you learn. So there are some of you who have done these questions. Some of these questions, they would benefit more out of it, because they would have seen those questions already once. They would have attempted those questions, and they would have known where exactly they're getting stuck. And then we could discuss those questions in our class. So that's going to be how you benefit the most from these classes. So please make sure that you do that as well, and let me know if you have any problems. So let's start with some of these questions then. So Hera is asking about question number 24 and 33. 33 we are going to do tomorrow, because that involves finding a specific term. The other one, 24 we'll do today, inshallah. Yeah, somebody asked me about this on the WhatsApp group yesterday as well. Let's start from another question right now that is maybe relatively simpler. So we start off with something, and then those of you who have not attempted many questions, you start understanding this as well. And then we'll do the relatively more complicated questions after that. So let's start with question number 1, for instance. Okay, it's a relatively simpler one. Then we'll do 24. Just to get started, to get up to speed, let's start with this one. So it's a relatively easier question, relatively simpler question on this topic. Let's start with this. Question number 1. Now, remember, this is the formula that you're going to be given in the formula sheet. This is the formula that's going to be given there. So what I'm going to do is I'm going to copy this formula in front of us here, so that we know that this is what we will have in the exam. So we know how to use this. Okay. Alternatively, you can just memorize the formula, but a lot of times you just end up forgetting things during an exam. So you need to have a backup. So that's why we are going to be using this formula, this form in particular, okay, when we're doing practice. So what are we asked about here? It says find the coefficient of x cube in the expansion of 1 plus 2x whole raised to power 6. Okay. Now, all you have to do in such questions is, so there are multiple ways of doing this. The way I recommend is just expand it like you would normally do. Okay, just expand it like you would expand any expression like this, and then you find where the coefficient of x cube turns out to be. Okay, so in this case, what you're looking for is the coefficient of x cube in the expansion of this thing in the first part. So where does x cube come? I would suggest you just use this formula and expand it. Expand it until you find that term that you're looking for. You're looking for the term in x cube, the coefficient of x cube, right? You just expand it. How do you expand it? The formula is a plus b whole raised to power n. Let's compare the two. In place of a, you have 1. In place of b, you have 2x. In place of n, you have 6. These are the values that you're going to input in the formula. In place of a, you input 1. In place of b, you input 2x. In place of n, you input 6. Let's input these values. You have a raised to power n. That means 1 raised to power n, which is 6, plus. Remember, n1, what does this stand for? This stands for nc1, right? This is nc2. This is nc3. So n is 6. We have 6c1 into a raised to power n minus 1. That means 1 raised to power 6 minus 1. Now, notice this pattern in the formula. The values of the powers of a, they are decreasing. You have n, then n minus 1, then n minus 2, then n minus 3. It keeps decreasing like this. Okay. So for every next term, you're just going to reduce this power. What about b? The powers of b are increasing. You have b power 1, b power 2, b power 3, and all the way up to you have b power n. So one power is going to keep increasing and the other power is going to keep decreasing. So you have 1 raised to power 6. In the next term, it becomes 1 raised to power 5. And you have b here. What's b? B is 2 times x. That's 2 into x plus the next term. That's this one. 6c2 into a, which is 1 raised to power 6 minus 2, which is 4. This power is going to increase now. 2x whole squared. Now, keep your eyes open in the sense that what were you looking for? You were looking for x cube. Do we have x cube yet? We have x squared already. So if we just expand one more term, that's 6c3 into 1 raised to power 3 into 2x whole cube, we get the x cube term here already. Now that means we do not need to expand this any further. We can just stop at this point and we can say, that's the term that we were looking for. Just ignore everything else. Just focus on this. You do not even need to simplify the rest of it. Just simplify this term. What's 6c3? You'll do that on your calculator. 6c3 turns out to be 20 into 1 into 2x cube. 2x whole cube is 8x cube. That gives us 160x cube. That's what we were looking for. The question says find the coefficient of x cube. So what can you say now? You can say the coefficient of x cube is equal to 160. That is what we were looking for. That's the first part. So that's one way of doing doing such questions. When you're looking for a specific term, just expand it using the formula, and that's pretty straightforward. Okay, and just find that specific term that you were looking for. Yes, Abdullah.
अस्सलाम वालेकुम सर।
Walaikum assalam.
सर, ये मुझे समझ नहीं आई, आपने बाकी जितना भी लिखा हुआ उसको आपने सोल्व नहीं किया, सिर्फ आपने 2x³ वाले पार्ट को सोल्व किया।
जी, बिकॉज क्वेश्चन कह रहा है फाइंड द कोएफिशिएंट ऑफ एक्स क्यूब। अगर उसने कहा होता ना एक्सपैंड करें, अगर उसने कहा होता एक्सपैंड करें, तो फिर तो आप ये पूरा सिंप्लीफाई कर लेते हैं। अभी उसने पूछा है कोएफिशिएंट ऑफ एक्स क्यूब क्या है, उसने सिर्फ ये पूछा आपसे। वी आर नॉट कंसर्न्ड विद द नेक्स्ट विद द अदर टर्म्स। हमें सिर्फ उसने एक्स क्यूब का कोएफिशिएंट पूछा था, बाकी आप सिंप्लीफाई करना चाहें तो कर लें। you'll get 1 plus 6 into 2, that's 12 times x, plus 62 is 15, 15 into 4, that's 60, 60x squared. You can do all of that, but that's not required. We were just looking for this 160. तो हमने कहा बाकी सब कुछ इग्नोर करते हैं. Why waste our time simplifying everything else? Just focus on the term that we were looking for. So the question was, why are we not expanding? Why are we not simplifying the rest of it? Because we don't need to. We were just looking for the coefficient of x cube, and we have that in this term. So we don't need to expand all of it. We just can simplify this term, and that will be enough. If they had asked us to expand the whole expression, then we would simplify everything. But here we don't need to do that. Okay. Abdullah, does that answer your question?
जी सर, थैंक यू सर।
Okay, Arham is saying, why won't we lose marks for not completing the other steps? Well, no, because they've not even asked about that. They have just asked us for the coefficient of x cube. That's all that we're looking for. We're not even asked about the other things. In fact, some people, some students are able to figure out this term directly. So there's a way to do that. We'll learn that later. And you could just write this directly as well, without even writing the other terms. That will be acceptable. You could just ignore the rest of the terms like this, and you could just write this term directly, and that will also be acceptable, because all that we were looking for was the coefficient of x cube, and that's this particular term. We don't need the rest of the terms. Is that okay? All right. Okay, let's look at the second part. So look at the question carefully, what they're asking about. They were asking about the coefficient of x cube. And we have found the coefficient of x cube. Writing this is necessary. Then simplifying this is necessary. These are the important steps. The rest is not required. Okay. All right. Now, the second part says, now this is important because you get such problems in binomial in every other question. The one that you have in the second part here. It says, find the coefficient of x cube in the expansion of this thing. Now you have two expressions here, two things being multiplied with each other. One is 1 minus 3x, and the other is 1 plus 2x whole raised to the power 6. Okay. What we are looking for is the coefficient x cube. That is what we are looking for. Okay. Now, let's do it one way first, and then I'll explain you a slightly quicker way of doing this that we will be doing later for other questions. One possibility is you just use the expansion that you've done in the first part. You've done this expansion in the first part, right? 1 plus 2x whole raised to power 6. Just write that here. And then multiply. And then look for the coefficient of x cubed. That is one possibility. Okay, so 1 minus 3x. You have 1 minus 3x here. Multiplied by 1 plus 2x whole raised to power 6. What's 1 plus 2x whole raised to power 6? We've done this here. Just multiply all of that. So let's write all of that. So write all of those terms. 1 plus 6c1 into 2x. You can do that here if you want now. 6c1 is 6 into 2. That's 12. You get 1 plus 12x plus 6c2 is 15. 15 into 2 squared is going to be 60. We have 60x squared, and then we have 160 x cubed from this. And then we could expand more, but since we are just looking for the coefficient of x cubed, we don't need to go any further than this. Okay, this is one possibility. This is one possibility that you just write down the whole expansion that you did in the first part here in place of 1 plus 2x whole raised to power 6, and then multiply everything. Multiply 1 with 1. Okay, let's do that. 1 into 1, then 1 plus 12x plus 60x squared plus 160x cubed. So we have multiplied 1 with everything here, and then multiply minus 3x with everything. That gives you minus 3x minus 36x squared minus 180x cubed minus 480x raised to power 4, and so on. What were we looking for? We were looking for the coefficient of x cubed. So now let's just look for the terms that have x cubed in them. We have 160x cubed. This is one term. And we have minus 180x cubed. These are the two terms that we are interested in, right? Look at the question again. It says find the coefficient of x cubed in this expansion. So we are just looking for the x cubed term. Where do we have x cubed? We have x cubed here and we have x cubed here. We just focus on those two terms and we say we end up getting 160x cubed minus 180x cubed. That results in minus 20x cubed. So what's the coefficient of x cubed then? The coefficient of x cubed that we have here is minus 20. That's what we were looking for. Okay, this is one way of doing this. Any questions on this? Does everyone understand this? Now, there may be a quicker way of doing this. We'll discuss that. But any problem with this? Yes, Abdullah?
सर मैंने पूछना था, ऊपर ब्रैकेट में जो है वो मल्टीप्लाई हो रहे हैं, तो हमें इनके कोफिशिएंट्स को मल्टीप्लाई नहीं करना चाहिए?
तो मल्टीप्लाई ही किया हमने, और क्या किया?
नहीं सर, बाद में आपने जो एक्स क्यूब के दो कोफिशिएंट्स हैं उनको आपने माइनस किया है।
नहीं, वो ब्रैकेट तो हमने एक्सपैंड कर लिया ना यहाँ पे। वो ब्रैकेट तो हमने मल्टीप्लाई
तो
करके यहाँ पे एक्सपैंड कर लिया।
ठीक है सर,
उसके बाद तो ये प्लस माइनस ही हो रहे हैं ना।
ठीक है सर।
उसके बाद तो प्लस माइनस हो रहे हैं। ओके, एनीथिंग एल्स?
नो सर।
Acha, this is one way of doing this. That you expand the whole thing and then you simplify. Okay, that's one way of doing this. Now, there's another possibility, and that's basically more efficient. And that's what we will be doing in most such questions. Because sometimes it's just not going to be practical to expand this whole thing. Okay, so you'll have to be a bit more efficient there. You have to think smartly. You have 1 minus 3x into 1 plus 2x whole raised to a power 6. What are we looking for? We are looking for the coefficient of x cubed. That is what we are looking for. Okay. What you're going to do is you're going to focus on the expression that does not have any power in it. Okay. This does not need binomial formula to expand, right? This does not have any power in it. You're going to focus on this. Okay, I'm sorry. You're going to focus on this bracket. And you're going to think about how you are going to get x cube as the result. Remember, what are we looking for? We are looking for the coefficient of x cube. That's the only term that we are concerned about. That's what the question says, right? We are looking for the coefficient of x cube. Now, how could we do all of this more efficiently, which is going to be really important for some questions. In this case, it doesn't really make a lot of difference because this is not a lot of working either. But in a lot of questions, you have to first figure out what specific terms you are going to need from this expansion. Now, let's understand what I mean by that. You're going to focus on this expression that does not have any power in it. You're going to focus on the expression that does not have any power in it. So that's 1 minus 3x. What do we want at the end? We want x cubed at the end. What are we going to multiply 1 with to get x cubed? There are two terms here, right? You want x cubed as the result. 1 is a constant. What do we multiply 1 by to get x cubed? What power of x will we need to multiply 1 by? We will need to multiply it with x cubed to get x cubed, right? Constant will need to get multiplied with x cubed to get x cubed. And what about minus 3x? What are we going to need to multiply minus 3x with to get x cubed? We have x power 1 here already. We want x cubed as our final result. We would need to multiply it by x squared. So in order to get x cubed as the final result, 1 needs to be multiplied with x cubed. That's one way you can get x cubed. And minus 3x needs to be multiplied with x squared. That's another way that you can get x cubed. Is that okay? This makes sense to everyone? Now what we do is we just focus on these two terms from that other expansion. We forget about everything else. We discard everything else. We say, let's just find out these two terms. The term that has a square in it, and the term that has a cube in it. Because that's all that we really need. We are not concerned about the rest of the terms because we can't get x cubed from the other terms. So in this expansion now, that we did in the first part, we're looking for the x squared term, and that's this one. What's that? 6c2 is 15. 15 into 4 is 60. So one term that we're looking from there is 60, x squared. And then the x cubed term, which one is that? That's 160x cubed. So from that expansion, these are the only terms that we need. We do not need the rest of the terms. So we just focus on these terms. Okay. Now, as I said, you could also do it the longer way like this. And that's okay. That's perfectly okay. It's just that it might take 1 extra minute. And that's all right in paper 1. Generally, you don't have time constraints as such, but this is what would be more efficient, that you only focus on the terms that you really need from that expansion. So you needed x squared term and x cubed term. And now, how can we get x cubed from this? 1 needs to be multiplied with the x cubed term, minus 3x needs to be multiplied with the x squared term. That's what we decided earlier, that 1 will need to be multiplied with the x cubed term, and 3x will need to be multiplied with this x squared term. And from that, we get 1 into 160x cubed plus minus 3x into 60x squared. We get 160x cubed minus 180x cubed, and that gives us minus 20x cube. So the coefficient of x cube is equal to minus 20. And that is what we were looking for. So this is another idea that you can use here, that you can ignore the terms that you know you do not need. So you first figure out which terms you're going to need from this expansion. Just focus on those terms. Forget about the rest of the terms. Does that make sense to everyone? Any problem with this? Any questions, anyone? No? Okay, I'm sorry, I missed the chat messages here. Yeah, okay, good. I hope that makes sense. So that was this question, okay? So a lot of times when you have to find a specific term like this, you first think about the terms that you need from this expansion and just focus on those terms, okay? That makes things quicker and more efficient. All right, let's move on to the next one. Okay, let's do that question first, that the one that you're asking about, question number 24. '33 will do tomorrow, inshallah, when we discuss how to find a specific term in an expansion. A proper method for that. Do that tomorrow. Okay, question number 24 from the worksheet. Let's have a look at this now. Let me copy the formula here. Okay, so we'll keep this formula in front of you. The first three terms in the expansion of 1 minus 2x whole raised to power 1 minus 2x whole squared into 1 plus ax whole raised to power 6 in ascending powers of x are 1 minus x plus bx squared. We need to find the values of the constants a and b. Okay, that's what we are looking for. We need to find a and b. So what they've done is they have given us an expansion already. They've given us the first three terms in this expansion, 1 minus x plus bx squared. What we can do is we can do our own expansion and then compare that with what they have given. Okay, so let's try that. So we're given 1 minus 2x whole squared into 1 plus ax whole raised to power 6. That's what we're given. Now 1 minus 2x whole squared, that's just a minus b whole squared. You don't even need the binomial formula for that. You can just use a minus b whole squared, right? To expand the first one, let's do that. That gives us 1 squared, which is 1, minus 2 into 1 into 2x, which is minus 4x, plus 2x whole squared, which is 4x squared. All right. Then this has power 6 in this. Okay. Now, this will need binomial. We can't do it without binomial, right? This will require us to use binomial. How do we do that? We use this formula that we have. A raised to power n. A is, so if you compare this with the formula, in place of A, we have 1. In place of B, we have A times X. And in place of N, we have 6. A raised to power N, that's 1 raised to power 6, plus NC1, remember this is NC1, this is NC2, this is NC3, NC1, that's 6C1 into a raised to power n minus 1, which is 1 raised to power 5 into b. What's b? B is a times x. A times x. Now, remember what we are given in the question. In the question, we're given this expansion 1 minus x plus bx squared. We have a constant term, we have x power 1 term, and we have x power 2 term. We have expansion up to x squared. We don't need to go any further than that. We only need expansion up to x squared. So we have x here. We need one more term after this. That becomes 6c2 into 1 raised to the power 4 into ax whole squared. We have square term already. That's it. We don't need to expand it any further. We'll just ignore the rest of the terms. And that's it. And now let's simplify everything. 1 minus 4x plus 4x squared into 1 plus 6c1 is 6. We get 6 times ax plus 6c2. Again, do that on your calculator. That will give you 15 into ax whole squared. That is a squared into x squared. Again, we are ignoring the rest of the terms. Now we do multiplication. This is the expansion that we have done. And this is what they have given us. Remember, we are only given the first 3 terms in the expansion and ascending powers of x. Let's do this multiplication now. 1 into 1, that's 1, plus 1 into 6ax, plus 15a square x square. That's 1 multiplied by each of those terms. Then we multiply minus 4x with each of those terms. That gives us minus 4x. Minus 4x into 6ax, that is minus 24 times ax. And then minus 4x into this, that is minus 60 a square. Okay, I'm sorry. I think this was minus 4x into 6x. That was x squared here. And then we have x cubed here. Minus 60 a squared x cubed. Now, since you only need terms up to x squared, you could also just ignore this term, right? If you wanted, you could just not write this at all. You just ignore this as well because you don't need it, right? And that will be okay. Then you have 4x squared into this. That's 4x squared into 1. That's 4x squared. 4x squared into 6ax. That would be 24a x cube. Again, we don't need this term. This is x cube. You could ignore this. Similarly, x power 4 as well. If you wanted, you could just ignore that. That's your choice. If you want to write it, that's also okay. 60a squared x raised to power 4. That's what we get when we expand all of this. Now what we're going to do is we're just going to look for the constants. What are the constants that we have? We just have 1. That's the only constant that we have. Okay. Then what about the x terms? We have 6ax, we have minus 4x, and that's it. These are the 2 x terms that we have. Let's write them together. Plus 6, because we need to write this in ascending powers of x, right? So we're writing the constant first, then the x terms. That's 6ax minus 4x. Then we look for the x squared terms. What are the x squared terms that we have? We have 15a squared x squared, and we have minus 24ax squared. And we also have this 4x squared. Let's write these terms together. That's plus 15a squared x squared minus 24 ax squared plus 4x squared. Now the rest of the terms have higher powers than 2. That's x cubed, x power 4. So we don't really need that. We just ignore the rest of them, right? We only need to expand up to x squared here. So that's what we need to compare, right? The first 3 terms. Now this is what we've got. Now the expansion that they have given, they have given us the coefficient of x, that's -1, the coefficient of x squared, that is b. We have multiple x terms here. So we need to figure out what our coefficient of x is in this case. So what's our coefficient of x here? Constant is just 1, but what about the coefficient of x? You can take x common, and that leaves you with 6a minus 4 times x. So this whole thing is the coefficient of x that you have now. Okay? And then you have the x squared terms. You can take x squared common from that to find the coefficient of x squared. What do you get from that? You get 15a squared minus 24 times a plus 4 whole into x squared. That's the coefficient of x squared that we get. Okay. And now what we can do is we can compare it with what they have given. They told us that the actual expansion was supposed to be 1 minus x plus bx squared. That's the expansion that they have given. That means this expansion that we have done and the expansion that they have given, they should be the same, right? So minus 1 here corresponds to this one. Well, 1 equals 1, that's obvious. We don't get anything useful from that. But if you look at the coefficient of x now, they have minus x. Minus x means minus 1 times x. So we can compare the two now. We can say 6a minus 4 should equal minus 1, right? So we get one equation from that. We get 6a minus 4 equal to minus 1. And that gives us 6a equal to 4 minus 1, which is 3. And the value of a turns out to be 1 over 2 or 0.5. And similarly, we can compare the coefficient of x squared. What's the coefficient of x squared? This is the coefficient that we got. And they have given us that the coefficient of x squared is supposed to be b. So they are supposed to be equal to each other. So we say 15a squared minus 24a plus 4, that has to equal b. Now, since we know the value of a, we can input that there. And that gives us 15 into 1 over 2 whole squared minus 24 into 1 over 2 plus 4 equals b. And now we can simplify this. We get 15 over 4 minus 12 plus 4 equals b. And you can see what the value of b turns out to be from this. Minus 8 plus 15 divided by 4. That's giving me minus 17 over 4. That's the result that I'm getting from this. Just check for any careless errors in this. Just check the answers as well. 1 over 2 and minus 7. Yeah, that should be correct. So a equals 1 over 2 and b equals minus 17 over 4. Okay. So they gave us one expansion themselves. They said that the first three terms are supposed to be this. We said, okay, let's find our first three terms. And then we just compare the two. And that gives us the values of a and b. Is that all right? Abdullah, do you have a question or do you have your hand raised from before?
Sir, I wanted to ask, how did you expanded 1 minus 2x whole square?
Well, a minus b whole squared. That's a squared minus 2ab plus b squared. So that's 1 squared, 1 minus 2x whole squared. That would be 1 squared minus 2 into 1 into minus 2x. No, sorry, into 2x, because we already have minus outside, plus 2x whole squared. That's 1 minus 4x plus 4x squared. Right?
सर तो हम इसके ऊपर वो एक्सपेंशन वाला फॉर्मूला नहीं इस्तेमाल कर सकते? क्या
कर
है
लें,
ये
वो
सिर्फ?
कर लें,
ओके ओके,
वो कर
ठीक
लें,
है सर। ठीक है
उससे भी
सर।
वही आएगा। बट ये तो आपको पहले से पता ही है ना, तो आप डायरेक्टली लिख सकते हैं। बट इफ यू वांट टू यूज बाइनोमियल एक्सपेंशन फॉर्मूला इन दिस एज वेल, यू कैन डू दैट, you'll get the same thing from that as well. Yeah. Okay. Yes. Does that make sense to everyone? Any problems?
सर
जी जी।
सर आपने ये जो है ब्रैकेट में 6a-4 इक्वल्स टू -1, ये इसकी मुझे समझ नहीं आई, ये आपने क्यों इक्वल पुट की है?
देखिए उसने क्वेश्चन में कहा हुआ था, दिस इज द एक्सपेंशन दैट यू शुड गेट फ्रॉम दिस, वी गॉट दिस। तो हमने बस कहा कि जो हमारा एक्स का कोएफिशिएंट आ रहा है वो -1 होना चाहिए, और हमारा जो एक्स स्क्वायर का कोएफिशिएंट है वो बी होना चाहिए। हमने दोनों को इक्वेट कर दिया बस। राइट। Arham, are you tired? Can we do one more question quickly? Can we do one quick question before we end? Okay, let's quickly do one more question. And then, so I'm not sure what you said yes on. Was that on, are you tired, or can we do one more question? Binomial expansion worksheet. Okay, let's try this. Question number 3 from the worksheet. Okay, a short one. Let's quickly do this and then we end. It has something that I wanted to tell you about as well, so you can do most of the questions from the worksheet after this. Achha, by the way, sometimes you'll see in questions, when you attempt questions, they will say the term independent of x. Okay, we'll do such questions tomorrow, inshallah. Sometimes they say that find the term independent of x. What that means is the term that does not have any x in it. So basically a constant, maybe 4, any constant, the constant term. It means you're looking for the constant term. Or in other words, you can say you're looking for the term that has x raised to power 0. Okay, that's just a point that you should remember when you do questions. We will do such questions tomorrow. When they say find the term independent of x, that means you're looking for the term that has x power 0, or you can say the term that is just a constant without any x in it. Okay, let's quickly do this question, then we end. We have this formula in front of us. Let's copy this here. Okay, so first part is pretty straightforward. It says find the first 3 terms in the expansion of 2 minus x whole raised to power 6 in ascending powers of x. Okay, 2 minus x whole raised to power 6. Let's do this expansion. We just need the first 3 terms. So a is 2, b is minus x. Do not forget the minus sign. N is 6. Just input values and the formula. A raised to power n, that's 2 raised to power 6 plus 6c1 into a raised to power n minus 1, that's 2 raised to power 5 into b, which is minus x, plus 6c2 into 2 raised to power 4 into minus x whole squared. And that's it. These are the 3 terms that we needed. We don't need to go any further than this. 2 raised to power 6 is 64. 6c1 is 6 into 2 raised to power 5 is 32 into minus x. 6c2 is 15. 2 raised to power 4 is 16 into x squared, because minus whole squared is something that's positive. Simplify this, and that gives you 64 minus 32 times 6. That's 160 plus 32, 192x plus 240x squared. That's the expansion that we have. That was the first part. We just had to expand the first three terms of this expansion. Okay, that was pretty straightforward, I think. The second part is find the value of k for which there is no term in x squared in the expansion of 1 plus kx into 2 minus x whole raised to power 6. Okay, we need to find the value of k for which there is no term in x squared. That means the expansion should not have any x squared in it. What value of k would we need for that? Okay, think about this. If I had something like this, 1 plus 2x minus 5, or let's say minus bx squared plus 3x cubed. And if I were to say, find the value of b for which there is no term in x squared in this expansion, what do you think the value of b should be? If I say find the value of b for which there is no term x squared expansion, if you don't want any term in x squared, what should b be? How can you eliminate x squared from this expansion? That's not very difficult.
Sir, by multiplying it by 0.
So b should be 0, right? So if b is 0, we would not have x squared at all, right? If the value of b was 0, x squared would get eliminated. All right? So that's the idea that we have to use here as well. We need to make the coefficient of x squared equal to 0. So if they're saying there's no term in x squared, that means the coefficient, they're telling us that the coefficient of x squared is equal to 0. That's what they're telling us here. Okay, you have to find the value of k such that the coefficient of x squared becomes 0. That's what we're looking for. Okay, so all we have to do now is find the coefficient of x squared in this expansion. What's the expansion that we have to do? It's 1 plus kx multiplied by 2 minus x whole raised to power 6. We have already found the first few terms in this expansion. 2 minus x whole raised to power 6. That's 64 minus 192 times x plus 240x squared. What are we looking for? We're looking for the x squared term. Again, we don't have to multiply this whole thing. You can if you want to, but it's not required. What would you multiply 1 by to get x squared? You want the x squared term, right? What would you have to multiply a constant by to get x squared? You'll have to multiply the constant with the x squared term, right? And what about the x term? What do you multiply x by to get the x squared term? You multiply the x term with the x term. That's the only multiplication that you need to do here. You can ignore everything else. If you wanted, you could also just multiply the whole thing. That's your choice. You can do that, but that's just going to take longer. You don't need to do that. You can just do these two multiplications, and that's going to be enough. So we have 1 into 240x squared plus kx into minus 192x. And we're just ignoring everything else. Okay, because these are the two terms these are the two products that are going to give us x squared. The rest are going to be either constant or x power 1 or x power 3 or x power 4. Maybe we don't need that. Okay, so what do we get from this? We get 240x squared minus 192kx squared. Okay, what do we get from this? What's the coefficient of x squared? The coefficient of x squared, if we take x squared common here, that's 240 minus 192 times a whole times x squared. If you want no term in x square, the coefficient of x square should be equal to 0. So we say this thing has to be equal to 0. So what do we get from that? We get 240 minus 192k equal to 0. You get k, or 192k equals 240, and k equals 240 divided by 192, which is 5/4 or 1.25. That's the value of k that would eliminate x square from this, because the coefficient of x square would become 0. 0 multiplied by x square is just 0. So there would be no x square in this case if the value of k was equal to 1.25. So when they say you want no term in a particular power of x, the coefficient of that power has to be 0. So you just find the coefficient of that power, like we did here. We find the coefficient of x squared that turned out to be this. We put that equal to 0. And that gives us the value of that unknown that we had to find. Make sense? Any problems with this? Any quick questions, anyone? No? Will you be able to do the whole worksheet now? You should be able to do most of the questions. There will be some questions that you will get stuck at. We will do our last concept on this tomorrow. After that, you should be able to do all of them inshallah. Okay. Let me know if you have any questions. We can discuss them. Otherwise, that's it for today. I'll see you again tomorrow. So those of you who want to leave, you're free to leave. If anyone has any questions, you can let me know. Allah Hafiz, everyone. Yes, Abdullah.
सर वांटेड टू आस्क, सर आपने 240 एक्स स्क्वायर माइनस 192 के एक्स स्क्वायर था, आपने इसको क्यों नहीं इक्वल टू जीरो पुट किया? आपने एक्स स्क्वायर कॉमन लेके 240 माइनस 192 के को इक्वल टू जीरो पुट किया।
एक्स स्क्वायर का कोएफिशिएंट 0 होना चाहिए ना।
यस
तो
सर।
एक्स स्क्वायर कोएफिशिएंट निकाला हमने, एक्स स्क्वायर कोएफिशिएंट ये चीज है। अगर
ओके
आप
सर।
वो भी कर सकते हैं, आप इस तरह कर लें 240 एक्स स्क्वायर माइनस 192 के एक्स स्क्वायर, इस पूरे को आप कर दें 0 एक्स स्क्वायर के इक्वल। यू कैन डू दैट, ये भी कर सकते हैं। एक्स स्क्वायर पे खत्म हो जाएगा वहां से और आपके पास यही चीज आ जाएगी फिर। ठीक है,
ओके सर, थैंक यू सर, अल्लाह हाफिज सर।
ओके, अल्लाह हाफिज।